Welcome everyone, and welcome back for those of you that attended and that is listened to the recording, the lecture on part one of our two-part series. We are going to be covering Kent County tornadoes, looking specifically at historical radar signatures for tornadic events spanning approximately the last 20 years for Kent County, Michigan. This presentation can stand by itself, so you are certainly welcome to listen only to this one if you would like to get to the focal point of this entire series, which is radar signatures for Kent County in terms of past tornadic events. However, I would encourage you, if you have not done so, to go back and listen to part one. There's a lot of good history and context and data and analysis that I believe will be helpful. So, for those of you that may not have joined in part one, or for those of you that did, just a quick refresher as to who I am. Firstly, I'm a licensed amateur extra ham radio operator. For those of you that are fellow ham radio operators, many of you are participants in SKYWARN, and I know that my audience here will primarily be geared toward those who are ham radio operators who participate in our SKYWARN nets. However, not everyone who is a Skywarn spotter is a ham radio operator. So with that having been said, I won't be focusing particularly on ham radio, but rather on Skywarn itself, specifically with radar observation. But you might ask the question, for those of you who don't know, why am I a Skywarn spotter? What kind of drew my interest to observing weather and watching radar specifically? Well, it really comes down to two things. Firstly, I've been interested for a while in emergency communications, hence the license for ham radio. And also, I have taken an interest specifically with tornadoes ever since the El Reno, Oklahoma tornado on May 31st of 2013. When I realized that ham radio plays a very vital and pivotal role in our county regarding weather observation, I determined to not only improve my ham radio knowledge and emergency communications knowledge, but also my weather observational skills and my storm spotting knowledge and my radar observational skills. And so, as an amateur weather enthusiast, certainly I wouldn't want to misrepresent myself. I'm not a professional meteorologist or climatologist in the field. That having been said, if you do notice anything factually incorrect, certainly please feel free to let me know. You can send me an email via qrz.com. My email is posted there, or you can simply leave a comment in the YouTube section below. I would welcome that feedback should you need to offer it. But in watching TV shows, weather TV shows to be precise, such as Tornado Alley, which was a popular one back in the day that the Weather Channel hosted with Jim Cantori, still a very famous meteorologist and face of the Weather Channel, of course. The Storm Chasers series with Dr. Reed Timmer that was hosted on the Discovery Channel and you can now find archived on his YouTube channel. And also, most recently, as of last year, the Storm Rising TV series, also starring Dr. Reed Timmer, about 10 years after Storm Chasers, now on Disney Plus. And so these TV shows, while yes, they were geared towards the general public, they definitely captivated my interest at the time regarding tornadoes. And that was the impetus for what later on would blossom into full-fledged weather observation, reporting, and radar observation. So that's who I am. So what are we going to look at this evening in terms of the overview of part two? Well, we already covered the personal introduction, and just as I did at the opening of part one, we're going to look at the three primary data sources that I used to build this presentation tonight before we get into the tornadic events themselves. So, regarding the tornadic events, we're going to be going all the way back to 2001, the year of the new millennia. And we're going to begin by looking at May 21st, 2001. Now, there was no radar data available for this event, unfortunately. Moving then to August 13th of 2002, September 23rd, 2006, July 6th of 2014, July 14th of 2015. Also for this 2015 event, unfortunately, no NEXRAD radar data was available either. August 20th of 2016, April 10th of 2017, September 11th of 2019, April 10th of 2021, and June 26th of 2021. And then we'll have some final conclusions and observations. As you can already presume, if you happen to be watching this after sometime after it has been recorded, I'm recording this in early 2022. We do not yet know what the spring storm season is going to mean for the West Michigan area. Climatologists have predicted that it will likely be an active and stormy spring season. We will see if that bears out. Certainly, however, it appears that their observations regarding our cold and snowy winter were definitely true. But before we get into the radar data, let's just briefly look at the data sources that I'm utilizing this evening. Well, firstly, I am using NOAA's, the National Oceanic and Atmospheric Administration's National Centers for Environmental Information Storm Events database. Secondly, I am utilizing NEXRAD GR Level 3 radar data from NOAA's National Centers for Environmental Information. And finally, I am using historical Storm Prediction Center convective outlooks. Doubtless some, if not all of you listening to this, know what all of those are, but just to very quickly overview what the last two are specifically, NEXRAD, or Next Generation Radar Data, is an older radar technology. At this point, there are newer ones that are utilized, but it's still very much heavily utilized to this day. GR Level 3 is the most current version of the GR Level series of radar programs. It is extremely good. The only one better than GR Level 3 is GR Level 2 Analyst, which will do 3D modeling. And then the Storm Prediction Center, based in Norman, Oklahoma, is the National Weather Service's center that, as the name would suggest, predicts specifically severe thunderstorms and everything associated with that throughout the continental United States. And the convective outlook would be, of course, the day 1, day 2, and day 3 convective outlooks that are issued periodically throughout each day. So those are the primary data sources that I'm using for this presentation. You are more than likely able to get to these yourself. I would encourage you, as a matter of fact, you can absolutely utilize these same sources and you can see the data that I am utilizing and you can perform your own studies. I would definitely encourage you to do that if you are able and interested. So let's look at our first tornadic event here. Beginning on May 21st of 2001. This is the first of 10 tornadic events that we will be looking at that have struck our county in this millennium. So May 21st, 2001. It actually didn't generate just one tornado, it generated four. The first of which struck at 1:35 p.m. in the afternoon, was on the ground for approximately 2 minutes, and then lifted at 1:37 p.m. in the afternoon. Now, as you doubtless know if you have studied your history of the Fujita scale and the enhanced Fujita scale, if you don't know, I would refer you back to part 1 of this series. Due to these tornadoes occurring in 2001, we are not yet utilizing the enhanced Fujita scale. So everything up until 2007, we're going to be using the classic Fujita scale. So what was this first tornado? Well, it was an F0 tornado with a max wind speed of 70 miles per hour, with a path length of 0.6 miles. The event narrative for this storm stated, quote, an F0 tornado touched down just south of Carlton Park Drive and moved north, ending just north of Chicago Drive. The tornado produced some tree damage and siding was peeled back on one home. The tornado produced maximum estimated wind speeds to 70 miles per hour, hence the F0 classification. Damage was not estimated in terms of the amount of monetary loss, but of course they were able to survey the damage at that time. Thankfully, no injuries for this first tornado on May 21st, 2001. The second tornado would strike about 50 minutes later at 2:29 p.m. and as with the first was on the ground for approximately 2 minutes, the second tornado lifting at 2:31 p.m. This one was stronger. It was an F1 tornado with a maximum wind speed of 80 miles per hour. A shorter path length, however, it was less than a half mile long. It was 0.3 miles, and it was approximately 50 yards wide. And the official event narrative stated, quote, a tornado touched down near the intersection of I-96 and Leonard Streets. It was classified as an F1 tornado, producing maximum estimated wind speeds of 80 miles per hour. It had a path length of only a quarter of a mile, with a width of 50 yards. End quote. Again, as with the first tornado on this day, the monetary loss was not estimated, and thankfully there were no injuries. So, moving on to the third tornado this day, this one started 10 minutes after the second at 2:40 p.m. This was on the ground for approximately a minute or less, and it was a weaker tornado than the second one, being an F0 tornado with wind speeds only of 50 miles per hour. It was a very short-lived tornado. It was on the ground for a tenth of a mile with a width of 50 yards. And the event narrative stated, quote, an F0 tornado with maximum estimated wind speeds to 50 miles per hour produced tree damage and knocked down a cinder block wall. The tornado had a path length of only a tenth of a mile and a width of 50 yards. Again, as with the previous two on this day, damage was not estimated regarding the money that was lost, but thankfully there were again no injuries. Moving on to the final tornado on this day, it had an approximate start time of 2:50 p.m., again about 10 minutes after the third tornado, with an end time of about 2:51. As with the third tornado, this was also an F0 tornado, but wind speeds were higher at approximately 65 miles per hour. But as with the third, it was only on the ground for about a tenth of a mile with a maximum width of 50 yards. There were no injuries with any of these tornadoes. Damage was not estimated with any of these tornadoes. The official event narrative for the final tornado in Kent County on this day stated, quote, an F0 tornado touched down very briefly between Alpine Avenue and 4 Mile Road. The tornado was 50 yards wide and had a path length of only a tenth of a mile. Maximum estimated wind speeds of 60 miles per hour caused some tree damage and also roof damage to an apartment. And so moving on to the slide now where we can see where these tornadoes were geographically located as I recreated these. And with other tornadoes, you'll also see approximate damage paths as well that I've created in Google Earth. Here we can see the first tornado struck in the Granville area. The second tornado struck northwest of 96. I should correct myself, northeast of 96, east of 131 in the Plainfield area. The third tornado struck between M37 or Alpine. It was east of M37 and west of US 131 and struck between those two highways. And then the final tornado struck in the Comstock Park area. And as we're going to see over time, there are definitely pockets of geographic regions that definitely seem to be inflicted by more tornadoes than others within our county. Interestingly enough, where I live, which is northwest of the city of Grand Rapids, that historically is least likely to get a tornado. But there are exceptions, as with the violent tornado in 1965 that I discussed in part one. So this concludes looking at the first of 10 tornadic events. Let's move on to the second, being August 13th of 2002, and here we can begin to analyze the radar data as well as the convective outlooks issued by the SPC, the Storm Prediction Center, on that day. But first, some facts about the tornado that struck. The start time was 8:30 p.m. and the end time was 8:33 p.m. So more of a classic storm as we would think about it here in West Michigan, not an early afternoon storm, but an evening storm coming across the lake. So, being a tornado that was an F0 tornado with maximum wind speeds of 70 miles per hour, being on the ground for 3 minutes, how wide was it and how long was it? Well, it had a width of approximately 100 yards and it was a mile long tornado. And so the official episode narrative stated, quote, an F0 tornado struck in northern Kent County during the evening hours of the 14th. It had maximum winds of approximately 70 miles per hour, ranking it as an F0 tornado on the Fujita scale. The path length was about a mile long and path width about 100 yards wide. End quote. The damage here was estimated, it was calculated, it was $40,000 with zero injuries, thankfully. I should mention, in case this is a question in your mind already, thankfully none of these tornadic events since 2001 caused any fatalities. They did cause casualties in the sense that they did produce injuries, some of them. But this one on August 13th, 2002 did not. So let's turn our attention now to the historical radar data. Here you can see in GR level 3, I've got a rather classic and widely used view where I've got reflectivity, base reflectivity at a zero point 0.5 degree angle on the left and base velocity at zero point 0.5 degrees on the right. So looking first at the base reflectivity, we can see here a squall line from the southwest traversing its way up northeast through Kent County, and later on it would impact Montcalm County. Well, this squall line was longer than the entire county itself, and as we're going to see, and as I covered in my segment on QLCS storms, quasi-linear convective systems, and how they can produce tornadoes, we're going to see this being a recurring theme. QLCSs, or squall lines, would often sneakily, as it were, produce tornadoes in our county. And something that we're going to see at the very end of this presentation is one of my primary conclusions, that we definitely need to pay attention to squall lines, at the very least because of the potential for straight line winds, but also for the potential of embedded tornadoes within the squall line. So the leading edge of this storm, as it impacted its way up through the Rockford area, a tornado struck just to the east of US 131 in the Rockford area. We can see plenty of rain here in this system, which is common with a squall line. In the velocity, we can also see an outflow boundary that is not particularly strong. And behind the leading squall line of this storm, we can also see other bands of convection forming, but not particularly strengthening in Ottawa County, as they likewise are making their way up from the southwest through northeastern Kent County. So let's look now at a radar still of the image, the moment, or at least as close to the moment that the tornado struck. Here you can see the red arrow pointing to the red square, exactly where the tornado touched down in the Rockford area. Do we see anything in terms of reflectivity that could indicate a tornado? Not entirely. Now, if you were to loop this closely and watch it more slowly, you could see a bit of cyclonic rotation within the squall line, but nothing actually that produced a severe thunderstorm warning, let alone a tornado warning. And as we look at the velocity on the right, do we see a velocity couplet? Well, you can see that there's something there right by the Rockford area. Is that a very small velocity couplet, or is it simply an artifact of radar? To be honest, it's inconclusive. So, as we make now our radar observations regarding this August 13th, 2002 event, what do we see? Well, we see that it was moderately rain wrapped, as I have mentioned, is common within squall lines. They will bring rain and wind. Do we see a clear hook echo in terms of reflectivity? No. Do we see a velocity couplet? Probably, perhaps, but it is so small and so minor that I would not, if I were watching this storm and reporting my radar observations, I would qualify it and say this is potentially a minor velocity couplet on radar, or it simply could just be a radar artifact. Was it indeed a QLCS, a quasi-linear convective system? Absolutely it was. But was it radar detected? That is really the burning question for all of these tornado events. I would say this one was not. And the reason being was that radar actually did not refresh in GR level 3 at the time between 8:17 p.m. and 8:32 p.m. That was uh, uh, that was approximately a 15-minute window in which the Rockford tornado occurred. So the still image that I showed you is where the Rockford tornado was essentially done, more or less. So what is the primary takeaway here? When severe weather strikes, we first of all need to stay indoors, stay safe, and stay alert to weather conditions. That is why radar observation by itself is not enough to be an effective SKYWARN spotter. Now, it's a critically useful tool. It's an extremely important tool, but it's not foolproof. There are times where our radar programs won't refresh. There can be different artifacts on radar, different issues with radar that you can learn about when you take radar observational courses. Radar itself is very, very good. However, it is not always 100% reliable. And as we can see here, it was not 100% reliable here for detecting, admittedly, a very difficult tornado to detect on radar. So moving to this slide showing exactly where that tornado touched down, you can see that it touched exactly in the Rockford area just to the east of US 131. Moving on now to the third tornadic event, we move ahead 4 years to September 23rd, 2006. This was an F0 tornado. This struck in mid-afternoon at 4:45 p.m., and it was only briefly on the ground. The maximum wind speeds for this storm were 70 miles per hour. It had a path length of 0.5 miles and a path width of 66 yards. Damage was calculated for this storm, and even though it was an F0 tornado on the ground for approximately a minute, it inflicted over $100,000 in property damage. That is quite a lot of property damage in terms of the monetary value inflicted for such a short tornadic event. The official event narrative stated, quote, an F0 tornado touched down about 2 miles north of Caledonia. It had a damage path of half a mile in length and 200 feet, or that is 66 yards, in width. Top winds were estimated at 70 miles per hour. So, as we see in the Storm Prediction Center's Day 1 convective outlook, we can see that at that time, Michigan, the central and southern portion of the lower peninsula, was in a slight risk, along with most of the Midwest United States from the Ohio River Valley extending down all the way into the Ark-La-Tex, into the Texas, Arkansas, Louisiana area. Other than that, however, there were no areas of enhanced or moderate risk that particular day, according to the 20Z convective outlook issued by the SPC. And they stated, quote, the SPC is forecasting severe thunderstorms expected over parts of the lower Mississippi, Tennessee, and lower Ohio valleys this afternoon and tonight. The NWS Storm Prediction Center in Norman, Oklahoma is forecasting the development of severe thunderstorms capable of producing damaging winds and a few tornadoes over parts of the lower Mississippi, Tennessee, and lower Ohio valleys this afternoon and evening. So the severe storms were forecasted to be south of the state of Michigan. But as we can see here, as we look at the tornado outlook, counties south of Kent were in that 2% risk due to that slight risk at the time. And in fact, southeastern Michigan, in the counties managed more by the Detroit National Weather Service office, they were in a 5% risk. And then as we can see, northern Mississippi, northwestern Alabama, central Tennessee, and central Kentucky were all in a 10% tornadic risk that particular day. The convective outlook went on to say, quote, this convection has resulted in a more stable or less moist boundary layer ahead of the cold front across Illinois, Indiana, and Michigan, with 500 joules per kilogram mean layer CAPE indicated. Joules over kilogram, that is mean layer CAPE indicated, or convective available potential energy. Quote, with little additional destabilization likely across this region due to cloud cover, expect a lesser severe threat across this region. Nonetheless, strong deep layer flow will support a threat for damaging winds or an isolated tornado or two with any sustained storms which could develop, end quote. So even though they did not believe that severe convection would arise, they nevertheless warned folks that because of the strong deep layer flow, there could be damaging winds or an isolated tornado or two with any sustained storms that could develop, and that indeed was the case here in West Michigan that particular afternoon. So moving on to the radar data, looking at, again, base reflectivity over on the left, we can see a tremendous amount of rain throughout this system here, and we can see single cell and multi-cell systems all of a sudden converging into a squall line coming up directly from the south. And this southern system would make its way up through northern Kent County and take a more easterly track up through Montcalm County when it finally exited the area. But as you can see, again, continuing to look at reflectivity, as soon as it impacted Kent County, there was a confirmed tornado warning that was issued. Shortly thereafter, there was a severe thunderstorm warning issued for northeastern Kent County. And as this system traversed its way up through Montcalm County, we can see radar indicated rotation, we can see hail cores, we can see a severe thunderstorm warning, and we can see a tornado warning issued for that county. Now, on velocity, again, we see, of course, those same warnings, and we can see some indication of rotation on radar, but not until we get into northern Ionia and Montcalm counties. So, let's take a closer look. Here is a radar still image of the moment that the tornado struck. You can see multicellular convergence here with a squall line impacting the Caledonia area. No real features on reflectivity to identify the tornado in that exact location. This was a spotter confirmed tornado, as a matter of fact, at the time. If you look specifically at where the tornado struck, you don't necessarily see any type of velocity couplet or marked inflow to the storm that would distinguish it from just the general pattern of velocity throughout the squall line. So again, as we continue to see, these squall line tornadoes can be difficult to spot on radar, and they can spring up very quickly all of a sudden. Now, there was a tornado warning issued very shortly thereafter, but again, looking at this moment on radar when the tornado itself struck, at least to the best of my knowledge and ability, I would not have been able to detect strictly from radar alone exactly where the tornado actually was. But what other observations do we see for this storm? We see again, due to being a squall line, that it is wrapped in rain. We don't necessarily see a hook echo in reflectivity or a velocity couplet, but as we have seen all along, it is indeed a QLCS, a quasi-linear convective system or a squall line. Now, was this radar detected? Radar was fully operational this time, in contrast to the other tornadic event 4 years previously. But at least as best I can determine it, radar itself was not sufficient to detect the tornado. This particular one actually was reported by a law enforcement officer who saw the tornado touch down, and 10 minutes later there was a tornado warning issued by the National Weather Service office in Grand Rapids. So, as with the previous tornadic event, don't take severe weather for granted, folks. Even storms that don't appear deadly, or even particularly severe, can produce surprisingly severe weather very quickly. So we just always need to be vigilant. We don't necessarily want to be the type of individuals that see a single cell storm and be like, oh, that's obviously a supercell and so forth, and we need to call that into the National Weather Service. But that so much isn't really the problem for our county. If we look at the historical radar data, is reading too much into radar, in my opinion. It's that these tornadic events can be trickier to spot on radar. And I know personally, I really appreciate the folks, the fellow radar observers who have trained me and mentored me and that I have sat under in order to better understand radar. So I really appreciate the team that we have here on Skywarn. It's not a solo sport, certainly, it's a team sport. And so for any of you fellow radar observers in Kent County, just know that I definitely appreciate your efforts because these tornadic events can definitely be tricky here as we look at them on radar. Nevertheless, even though it wasn't easily detectable on radar, we can see the damage that it did to this dairy farmer's barn in that it completely peeled the roof off of his barn, which is where the $100,000 in property damage came from this particular time. And in looking at where the tornado struck, we can see that it struck just to the uh, west of M37, not in the Alpine area, of course, but in to the south of M6 and to the east of US 131 in the Caledonia area. And that concludes our third tornadic event. So let's move on to the big one. The big tornadic event that we have experienced in the last 20 years would be the July 6th, 2014 tornado. This, again, was a surprise tornado, but it was on the ground for 10 minutes beginning at 9:20 p.m. in the evening. It was on the ground for 10 minutes. It was a stronger tornado with maximum wind speeds of 110 miles per hour, making it an EF1 tornado. Since we've now jumped 9 years from the 2006 tornado to the 2014 tornado, within that 9 year sabbatical, we also have transitioned from the Fujita scale to the enhanced Fujita scale. And so now here in 2014, this is the first tornado in Kent County that deploys that enhanced Fujita scale. And so we have this EF1 tornado on the ground for 10 minutes, maximum wind speeds 110 miles per hour, a path length of 6.25 miles with a maximum width of 400 yards. 6 casualties, that is 6 injuries, that all required brief hospitalization. Thankfully, no fatalities. But the big problem from this tornadic event was the $4.5 million in property damage inflicted in those 10 minutes that this storm was on the ground. The official episode narrative at the time stated, quote, an EF1 tornado struck southern Kent County during the late evening hours of July 6th, resulting in widespread damage, including numerous downed trees, power lines, and damage to numerous homes and other structures. There were 6 injuries, but no fatalities. End quote. Now, the official event narrative stated, quote, an NWS storm survey determined that an EF1 tornado developed rapidly near 64th Street and Burlingame Avenue in Byron Center and tracked northeast for 6.25 miles through Wyoming and Kentwood. The tornado, on the ground for about 10 minutes, produced significant damage, and that's indeed true, if not in fact an understatement, in that it produced $4,500,000 worth of property damage. I knew people, and I'm sure perhaps some of you may have known people or known of people as well, who were directly impacted by the damage that this tornado inflicted back in 2014. So let's look at the SPC convective outlook for this storm before we look at the historical radar data. So this day one convective outlook issued at 1Z stated, quote, that it introduced a focused categorical slight risk over portions of North Dakota where a small cluster of severe thunderstorms persists within a largely unidirectional low mid-level flow regime and in the presence of modest instability. These storms will likely continue moving southwesterly with a threat for mainly damaging winds and large hail over the next few hours. And indeed, we can see that portions of northwestern North Dakota are in a slight risk, and that all except for the northeast portion of the lower peninsula is also included in that slight risk, along with the northwestern corner of Illinois, the northern half, or rather the northwestern corner of Indiana, the northern half of Illinois, the northeastern corner of Missouri, the eastern half of Iowa, and the southern and central portions of Wisconsin, as well as including most of the Upper Peninsula that day as well. The remainder of the United States, by and large, was in a general thunderstorm outlook at that particular time. No enhanced, no moderate outlooks in this particular day. And in fact, as we turn our attention now to the tornado outlook, you can see that, again, following those slight risk areas, northwestern North Dakota is in a 2% tornado risk, but Michigan, all of Michigan, in fact, is not in a tornado risk at all. The areas within that 2% tornado risk would be the northeast corner of Missouri, the northern half of Illinois, south and central Wisconsin, and the eastern half of Iowa. Now, this produces an interesting point in that whenever there is severe weather in Wisconsin, in the Milwaukee area, or in Illinois in the Chicago area, I would suggest it would at least be prudent to maintain a watch on that. Whether a net would be needed or not for ham radio is a different question, but nevertheless, I do believe that we need to maintain a watch on weather that close to our location. Because as we can see, an EF1 tornado that was on the ground for 10 minutes that produced damage in excess of $4.5 million occurred in a region to the east of, but not in the 2% tornado risk that particular day. The convective outlook goes on to say, quote, evening upper air data from KDVN confirms substantial capping remains in place across southern portions of the slight risk area in advance of a southern westerly moving cold front. Severe thunderstorms will remain possible tonight as a shortwave embedded trough within northwesterly flow aloft provides large-scale ascent over portions of the Midwest. However, coverage is not expected to be as widespread as previously anticipated. And they go on to mention how they, quote, also adjusted severe probabilities and categorical slight risk across the western portion of the slight risk for current frontal location. So, on paper, we were not supposed to ever get this tornado, but nevertheless, of course, we did. So here is the first of many radar loops that we can look at regarding this particular storm. Before we examine Kent County, in terms of the reflectivity features on radar, let's just briefly touch on what we see to the north of us in Muskegon and Newaygo and Montcalm counties. We can see multi-cell storm systems that continue to strengthen as they move further and further inland. We can see that Montcalm County is under severe thunderstorm warning. We continue to see relatively small hail cores continue to pop up, but as that system moves further and further inland, we just see stronger and stronger convection take place. And now to the multi-cell system that would turn, in fact, into a supercell that would generate that tornado. We can see that as it comes across the lake, as it moves east towards Kent County through Ottawa County, we can see that, waiting for this radar loop to generate again, we can see that most of Ottawa County was in a severe thunderstorm warning. Now, why that severe thunderstorm warning was dropped as soon as the system entered Kent County when it was only continuing to intensify rather than weaken, I'm not entirely sure. As I said, I'm not a professional meteorologist, and I very much appreciate the work that the professionals do at our Grand Rapids office. And it's inspiring for amateurs such as myself to just continue to better appreciate their depth of knowledge and skill. But nevertheless, I'm not entirely sure why a severe thunderstorm warning was not continued as this storm system continued to move east into Kent County. We can see that large multi-cell system generate clear rotation on radar, both in terms of the reflectivity and also in terms of the velocity as well. We continue to see hail cores popping up on radar, increasing and diminishing over time, indicating 1-inch hail was certainly possible. After the tornado struck down, there wasn't even a tornado warning ever issued. There was a severe thunderstorm warning issued for the northeastern portion of Kent County, which was after this EF1 tornado had already gone through the area. So let's move in and take a closer look at this tornado. Looking now at this radar loop, we can see, beginning with base reflectivity, slowing it down, we can see a tremendous amount of convection, a wide area of convection moving through the Wyoming, Kentwood, and Cutlerville neighborhoods, extending up into East Grand Rapids as well. And as it impacts the neighborhood to the north of Byron Center, in southern Wyoming essentially, or western Kentwood, we can see a hook echo clearly indicated here on radar as it begins looping around now. And in fact, GR level 3 throughout that warning that indeed there was radar rotation indicated. And now, turning our attention to velocity, we see that same warning with the velocity product, and we can see a clearly defined velocity couplet making its way up northeasterly, indicating cyclonic rotation, of course, being in the northern hemisphere, moving its way up through southern Wyoming, through Kentwood, and ending in southern East Grand Rapids. This actually did not pass far from the National Weather Service office at the time. Taking another look here at another radar loop, we can see again that clearly defined hook echo on reflectivity over on the left, and we can also see as this loop restarts, we can see near the Jamestown area at the county line, the Ottawa County line, we can see rotation indicated on velocity, and we can see that turn into a well-defined velocity couplet on radar. Again, there was no tornado warning, let alone a severe thunderstorm warning issued for this storm until after the EF1 tornado had inflicted its $4.5 million worth of damage and caused 6 injuries at the time. Here's a still image of where the tornado first struck down. Again, you can see that hook echo starting to form on radar, and you can also see that velocity couplet beginning to form as well. And in fact, in the previous loops, we saw that in reality, that rotation truly began near the Ottawa-Kent County line, just to the east of Jamestown, that is just to the west of Byron Center at the time. Here's where the tornado ended. The tornado ended just to the south of East Grand Rapids at the time, just to the northwest of the Grand Rapids National Weather Service office. And you can see that when this radar image was taken, you can still see that rotation indicated by that velocity couplet on radar. And at this particular moment, as the tornado was lifting off, you can now see that severe thunderstorm warning being issued by the National Weather Service office. So what observations overall do we make of this storm? I would say that there was intense rain wrapping just looking at the radar data. And the problem with rain wrapping is that when you have these systems that do not necessarily behave like the classic systems in Tornado Alley or in Dixie Alley, where you've got a rain-free base and so forth, they are harder to spot when they are shrouded in rain, and more dangerous as a result in terms of inflicting injuries for those who are not paying attention to the weather. Did we see a hook echo with reflectivity? Yes, of course we did, as well as a velocity couplet, a well-defined one, in fact. This, unlike the other tornadic events that we have seen up to this point and will continue to see after this 2014 event, was not generated by a QLCS. It did not arise from a squall line. But we do see that multi-cell convergence forming a supercell and thus the EF1 tornado. Now, interestingly, as I've stated before, this tornado was clearly visible on radar, and GR Level 3, in fact, numerous times identified the rotation a few minutes prior to the tornado touching down, but there was no warning ever issued. So again, even with radar, we need to ensure that we keep our weather observational skills sharp, being safe first and foremost, and that we take shelter and appropriate precautions when severe weather is looming. And I would suggest that if we see severe weather in our surrounding counties, whether or not those warnings are extended into our county immediately, that we effectively act as if they were, because radar and warnings do not always proactively identify severe weather that will impact you. Sometimes they identify the weather that unfortunately has already impacted you. Here are pictures of that impact. Looking at the tornado damage, looking at just a small portion of that $4.5 million in property damage, we can see a tremendous amount of tree damage, which crushed homes, crushed vehicles. We can see siding, shingles, roofing torn off of houses. Thankfully, there were no fatalities in this storm, and you can read more about it with the news reports on mlive.com. And as the storm system began in the just to the west of US 131, right along the M6 US 131 border, and extended its way up through the South Wyoming, the western Kentwood, and just the southern outskirts of East Grand Rapids, we can see the approximate damage path of that storm. And you can see off to the east the Gerald R. Ford International Airport, which of course the National Weather Service office is located right there. So this was a significant tornadic event, and one that I hope certainly we do not beat anytime soon. This was the big one, as I said, in terms of the tornadoes that would impact our county in the last 20 years. But we're not done yet. Let's move on to the next year, July 14th of 2015, which is our 5th out of 10 tornadic events this evening. This one, thankfully, was not as strong or potent as the EF1 tornado that struck the year before. This tornado was an EF0 tornado that struck not in the evening hours, but in the early morning hours on July 14th. It struck at 1:15 a.m. in the morning, and it was on the ground for 2 minutes with a maximum wind speed of 85 miles per hour. The length was almost a mile long at 0.8 miles with a width of 50 yards. There was approximately $50,000 worth of tornadic damage at the time, but thankfully no injuries. The official episode narrative stated, quote, severe thunderstorms developed during the late evening hours of July 13th and continued into the early morning hours of July 14th, resulting in several reports of wind damage, including downed trees and power lines. An isolated EF0 tornado also briefly touched down. End quote. The event narrative stated, quote, an NWS storm survey concluded that an EF0 tornado touched down about a third of a mile southwest of 84th Street and Morse Lake Road in Alto. The tornado had a maximum path width of 50 yards and was on the ground for about 2 minutes. End quote. As has been our custom up to this point, before we dive into the radar data, let's look at the convective outlooks, beginning first with the categorical outlook. Now you can see that our area was under a marginal risk at the time, with the southwestern corner of the lower peninsula in a slight risk. That slight risk would extend through central Wisconsin, through western Illinois, through central Missouri, through portions of Kentucky, all the way through most of Tennessee, into the corners of Alabama, Georgia, South Carolina, and western and central North Carolina as well. However, we also see that an enhanced risk encompassed most of the state of Indiana, a lot of the state of Kentucky, north central Tennessee, the eastern half of the state of Illinois, and the southeastern corner of Wisconsin. But that moderate risk encompassed the uh, north central region or the central region of Illinois, the western half of Indiana, and then the central portion of Kentucky. And the summary stated at the 1Z convective outlook, quote, multiple rounds of severe thunderstorms capable of damaging winds, tornadoes, and large hail are likely through tonight across much of the Midwest, but especially across portions of Illinois, Indiana, Kentucky, and southwest Ohio, as indicated by the categorical risk. The tornadic outlook shows much of the state of Illinois, much of the state of Indiana, and most of central Kentucky in a 5% tornado risk. And we can see the 2% region, the outer ring around the 5% area, extending into southwestern Ohio through northern Tennessee, through just along the Illinois-Missouri border and into central and southeastern Wisconsin, as well as southwestern Michigan, that is the lower peninsula. And the convective outlook goes on to say, quote, the air mass across southern lower Michigan will continue to moisten and destabilize with the approach of the upper Michigan shortwave trough, with moderate instability and sufficient shear for organized storms to move into and/or develop across mainly southwest lower Michigan through tonight. And that's exactly what happened. They were spot on with that forecast there. And as I stated at the beginning, unfortunately for this tornado, we have no radar data available. There was none available when I went to download it from the database. So while we don't have the radar features for this storm, thankfully, apart from this storm in 2015 and the one in 2001, we have radar data for all the others. But for this storm, we can see that it struck in the southern Alto neighborhood, in an area actually I've never heard of, even though I've been a resident of West Michigan my entire life, in Bowne, Bowne. I may not even be pronouncing that correctly. As I said, I've never heard of it. Bowne Center or Bound Center. Haven't heard of it, so don't know how it's pronounced. But nevertheless, we can see that northeastern track just to the south of Alto there along the Kent County, Ionia County line. This, of course, would be southeast of the Grand Rapids Airport, the Gerald R. Ford International Airport. So moving ahead to our sixth out of 10 tornadic event, in August 20th of 2016, we see another tornado striking our county. This one would also be at around 1:30, but this time not in the morning, this time in the afternoon. This tornado struck at 1:34 p.m., was on the ground for less than a minute. It was an EF0 tornado with maximum wind speeds of 85 miles per hour. The length, I believe, was a quarter mile. You'll see here on the slide I had listed it as 4.5 or 4.25 miles. So I would need to confirm whether the length or the time would be incorrect here on my slide, but nevertheless, we see the width was 75 yards and the event narrative stated, quote, "The fourth tornado of the day, not the fourth tornado that struck in Kent County, but that is the fourth tornado within the larger system, the first of the day in Kent County, was an EF0 tornado in southwestern Kent County. Along the path, hundreds of trees were damaged or knocked over, resulting in tens of thousands of power outages. Many homes and a number of vehicles were damaged from fallen trees." And we see damage being approximately $500,000. Thankfully, no injuries. The second tornado of this system in Kent County, that is, not the second tornado of the day from this overall system, but the second Kent County tornado struck at 1:50 p.m., about 20 minutes later, and was on the ground for 2 minutes. Again, this was an EF0 tornado, but the wind speeds this time were 85 miles per hour. The length was 0.9 miles, and the path width was 50 yards. The event narrative stated, quote, "A brief EF0 tornado touched down in Kent County near Perkins Avenue Northeast, between Leonard Street Northeast and Knapp Street Northeast. Tree damage and some property damage from fallen trees occurred as the result of this brief tornado. No injuries, thankfully, but $25,000 worth of property damage occurred as a result of this 2-minute EF0 tornado." Now, I know this neighborhood because that's near where I grew up, so I know this neighborhood very, very well. I know exactly where they're talking about. As a kid, I used to ride my bike through these streets many, many times. I knew these streets like the back of my hand. So looking at now at the categorical outlook from the 1630Z Day 1 convective outlook issued by the SPC, we can see that all of the lower peninsula of Michigan is within that marginal risk, all of Indiana, as well as the southeastern portion of Illinois, the western half of Kentucky, and the northwestern corner of Ohio are included within that marginal risk area as well, with the remaining portion of the eastern United States as well as the southwestern United States in a general thunderstorm outlook. And the convective outlook stated, quote, "A few marginally severe storms with strong to locally damaging wind gusts may develop across the Great Lakes region into the Ohio Valley this afternoon." They were spot on with that because that's what indeed happened. But one thing that did occur was less than 2% of all areas in the continental United States were in a tornadic risk that particular day. But nevertheless, we do see that a tornado touched down here in Michigan. But fascinatingly, the convective outlook goes on to say, because this would also prove true, quote, "A strong upper trough over the upper Midwest this morning will continue moving across the Great Lakes region through tonight. A low over Wisconsin at 16Z will develop and deepen through the period in response to large-scale ascent preceding the upper trough. A cold front extending from the FSC low in Wisconsin will move eastward across the remainder of the upper Midwest and into the lower Great Lakes and Ohio Valley regions by this evening." And they were spot on with that particular forecast there. So now, diving deep into the radar data here, we can see, first of all, just very first appearances here, we can see a lot of rain extending through West Michigan here. Before looking specifically at Kent County, we can see that this storm system, the convection that occurred to the southeast of us in Berry County, Eaton County, extending up through Ionia County before it would make its way up to the other counties to our northwest, generated not only severe thunderstorm warnings, but also generated tornado warnings as well, because you can see very clear velocity couplets over on the right in Berry and Eaton counties. Now, for our own county, you can see that large multicellular storm with that clear cyclonic rotation is indicated both on reflectivity and velocity. You can see that it had generated a severe thunderstorm warning in Allegan County, in Ottawa County, extending up through the western half of Kent County until it turned into a tornado warning a confirmed tornado warning. And GR level 3 through all sorts of rotational icons on the screen. As you can see here, this tornado was very easily identifiable on radar. And you can see now over on the right that well-defined velocity couplet as this image loops around again, making its way through western Kent County along the 196 corridor, extending up through downtown Grand Rapids, and finally breaking apart as it exits northeast of the Rockford area at the time. The tornado warning, in fact, covered almost the entire county at that particular moment. Just an impressive display of what radar can in fact do when it is able to capture these storms in good detail. This is an example here of where radar really shines when looking at these storms and observing how the storms are behaving and what they will do. Here's a closer look at the image, again looking first at the base reflectivity on the left of the slide here. We can see the radar loop showing even on reflectivity, that strong cyclonic rotation here, which generated the pink tornadic warning, which for those of you who might not know, when utilizing the stock colors in GR level 3, the pink color indicates a confirmed tornado has touched down, whereas red would indicate a radar indicated tornado. And again, we can see accompanying those tornado warnings, we can also see that severe thunderstorm warning as well. I remember this tornado quite well for two reasons. First of all, because it impacted someone that I knew at the time. And secondly, because I was working that particular day. I believe this was a Saturday, and my friends and I, in that particular year, I was not a SKYWARN spotter, but nevertheless, my friends and I working that particular day, it was a slow afternoon, and so we were glued to Wood TV8 and to other news stations because we all knew people who lived in this area. It was where we ourselves lived and worked, of course, and so we were quite concerned, not so much for ourselves, working just down the street at the time from the National Weather Service office. We were in a large office building deep within the interior, protected by many load-bearing walls. And so we were not concerned for our own safety. We had more than enough shelter at the time. But nevertheless, we were all concerned for our friends and family who were directly in the path of this storm. I'm very grateful that this tornado lifted as it went over my parents' neighborhood at the time and did not impact them. And it touched down to the south of them and to the north of them, but it lifted as it went over their neighborhood, and I'm very grateful for that. Looking at velocity, we can again see that very clearly defined classic textbook velocity couplet over on the right, coming up from the Jamestown area, extending up through Wyoming and Grand Rapids, and continuing on up until it exits the Rockford area at approximately 2:15 in the afternoon. Looking now at a still image of when that radar touched down, we can see that, again, classic textbook. I always love when things are textbook because they make it so much easier to identify. That textbook velocity couplet over on the right with that confirmed tornado warning already issued, which is absolutely fantastic that the Weather Service was able to issue that when the tornado touched down rather than minutes later. We can see that storm producing that rotation and that convection that would impact the neighborhoods of Wyoming and Grand Rapids and also more of the Northview area as well. Here's where the tornado lifted. It lifted just to the north of the Ford Freeway. And as you can continue to see, that velocity couplet is still well defined on radar. The tornadic warning is still in effect along with the severe thunderstorm warning. People were prepared. News agencies were covering this very thoroughly. Radar really shone in this particular instance. And so, what overall radar observations do we make? Well, we see again a lot of rain. I remember from firsthand accounts that people described they couldn't really see the tornado because it was just raining too hard at that particular time. We can see a hook echo with cyclonic rotation on reflectivity, a well-defined velocity couplet. This wasn't a QLCS, it wasn't a squall line, but nevertheless, we can clearly see this supercell visible on radar. And so the takeaway from this storm is be attentive to weather alerts. However you get them, and I recommend you get them in multiple different ways so that way you don't have a single point of failure when it comes to getting your weather alerts, such as multiple apps on your mobile phone, a weather radio or two, depending on where you're at, paying attention to radar, both on your phone and on your computer. I encourage you to have radar programs available on every mobile device and on every computer that you own. And also, of course, just paying attention to the weather outside as well, while obviously staying safe. Have multiple ways to stay attentive to these alerts that are issued for your own safety because they really did warn the Kent County community that day. And I well remember this particular event. And so people were able to take the appropriate shelter that they needed. Here's a picture of that damage that was inflicted at the time. You can see that tree fallen over on the house. And you can see, as I mentioned earlier, how that tornado lifted as it went through the Grand Rapids area and over my parents' neighborhood at the time. You can see how the, during the first cycle, it touched down in Granville and it ended in northern Wyoming. It then skipped over downtown Grand Rapids completely and then touched down again in northeastern Grand Rapids until it diminished just to the south of 96. Moving on now to April 10th of 2017, our seventh tornadic event, we see an EF1 tornado with maximum wind speeds of 90 miles per hour touching down for 4 minutes beginning at 7:36 p.m. This one was on the ground for 3.32 miles with a width of 75 yards. It inflicted $200,000 worth of property damage at the time. The event narrative stated, quote, an NWS storm survey confirmed that an EF1 tornado occurred with peak winds of 90 miles per hour and a path width of 220 yards. Dozens of large trees were blown down and there was significant damage to several outbuildings. Looking, of course, at the episode narrative as well, quote, an isolated EF1 tornado developed over extreme southeastern Kent County during the evening hours of April 10th. Dozens of large trees were snapped or uprooted and 3 barns were heavily damaged. The damage began on 100th Street, just east of Alden Nash Avenue. So let's look at the convective outlook issued at 20Z on April 10th of 2017, the day one convective outlook. We can see that the lower half of the lower peninsula is in that slight risk, along with the extreme northwestern corner of Ohio, the northern half of Indiana, the northeast portion of Illinois, and the southeastern corner of Wisconsin. And then the marginal risk category extends down through the Ohio and Tennessee and Mississippi River valleys until we get to the Arklatex, to southeastern Texas, to the corner, the Arkansas, Texas, Louisiana corner. And off to the Pacific Northwest, of course, we also see a general thunderstorm outlook, but that doesn't concern us at this particular moment in time. So the slight risk area that we were under, the SPC stated, quote, scattered severe thunderstorms capable of hail and wind are most likely through this evening across parts of the Midwest and south central Texas to the Arklatex, or that is, Arklatex is simply the term that's often utilized to refer to the Texas, Arkansas, Louisiana corner there. Looking at the tornadic outlook, we can see that our area and the lower half of the lower peninsula was all within that 2% risk, as well as northeastern Illinois and the northern half of Indiana, again matching that slight risk from the categorical outlook. And the convective outlook goes on to say, quote, widely scattered elevated storms are ongoing from Michigan to the St. Louis area. Isolated severe hail and gusty winds will be possible with embedded stronger cores. In the wake of this midday activity, surface-based storm development appears most likely to emanate out of the mid-Mississippi Valley, near south of a reforming surface cyclone that should become the primary frontal wave downstream of the eastward moving shortwave trough over New England. Here on radar, we can now see how that would actually play out in Kent County and in the surrounding counties. As we can see at this, on the left, as this radar loops back again, we can see to our north a lot of rain in northeastern Kent County, Montcalm County, Newaygo County, but in Kent County proper, we see a squall line bowing out in the middle, indicating the potential for high winds according to the what we see on the outflow boundary, and we can see that the southern half of Kent County received a severe thunderstorm warning. The tornado which struck in that QLCS, embedded in that QLCS, struck at the extreme southeastern corner of Kent County and extended north of Lake Odessa into Ionia County, as you can see with that confirmed tornado warning that was issued there. But to our south, there was a multicellular storm structure that was producing some concern. You can see a strong hail core as it makes its way through Allegan and Berry County, but thankfully it did not traverse north enough to impact southeastern Kent County again after the leading squall line had already passed through. And you can see the convection weakening as it makes its way further inland. But you can see special marine warnings for the Allegan shoreline, a severe thunderstorm warning for Allegan County, and of course, as previously mentioned, the severe thunderstorm warning for Kent County, and then later on the confirmed tornado warning. So let's look more closely at what we see here on radar. So here is a closer and slower radar loop of what occurred that day. We can see that we were already under a severe thunderstorm warning due to that rapidly moving squall line, that quasi-linear convective system. We can see exactly where the tornado struck down as indicated by the marker that I've placed on the radar map here. And we can see that as the tornado struck down, we can see rotation being indicated by GR level 3. And very immediately after the tornado struck down, we can see that a confirmed tornado warning was issued by the National Weather Service here in Grand Rapids. And now looking at the velocity, the base velocity over on the right, as that squall line makes its way through, you can see those defined outflow boundaries, which all of a sudden rotate into a textbook velocity couplet that makes its way up just to the south of Clarksville before it dissipates and the confirmed tornado warning was dropped at that moment in time. Looking at the still image on radar, you can see in the upper regions of convection that it is indeed producing a bit of a hook echo on reflectivity. We can see GR level 3 continuing to recognize the rotation that has developed within that storm. We can see the National Weather Service office already had issued that confirmed tornado warning, and we can see right along the county border that well-defined velocity couplet. And so the other observations we can make from this is that, common with squall lines, we can see that this tornado was wrapped in rain. We can see a hook echo this time, which is not always present on radar with a QLCS. We can see a well-defined velocity couplet. Again, that's not always present with tornadoes embedded in squall lines. We can see that it is in fact a squall line, and we can just see how well radar shined in this particular instance. Now here's an interesting takeaway. You can form many takeaways from each of these tornadic events, but the one that I chose to take away from this event is that as SKYWARN members, and I know that this is intuitive, but it's certainly a good reminder for myself and hopefully for others as well. As SKYWARN members, we are responsible to observe weather for all portions of Kent County, even areas that do not impact us. I dare say that this tornadic event impacted virtually no one on the SKYWARN team. Perhaps it did. In fact, I'd be curious to know if, in fact, it did. But because it was on the border, virtually on the southeastern corner of Kent County heading into Ionia County, thankfully the impact to our county was largely mitigated as a result. Looking at the approximate damage path, we can see again that this tornado struck down in Bone Center south of Alto. And if someone knows how that's actually pronounced, please feel free to let me know. That would be great. And it extended through a slight northeastern track and ended in Ionia County to the southwest of Clarksville at the time. And this concludes the April 10th, 2017 tornado. And so that brings us a couple years later to September 11th of 2019, our 8th of 10 tornadic event this evening. And so this EF0 tornado with maximum wind speeds of 72 miles per hour struck down at 6:43 p.m. in the early evening and was on the ground thankfully for less than a minute. The path length in fact was extremely short. It was only 0.05 miles, not even a tenth of a mile, with a maximum width of 25 yards. As such, damage was not estimated at the time and there were zero injuries as a result. But the episode narrative brings a recurring theme that we have seen repeatedly with how tornadoes form in our county, and that is our classic culprit, the QLCS. The episode narrative states, quote, a quasi-linear convective system, a QLCS, produced wind damage along a 50-mile long and a half to 5-mile swath that cut through parts of downtown Grand Rapids. Significant wind damage was observed within to just east of the city. The event narrative stated, quote, apartment building on Fairview Avenue Northeast just east of Division Street had the roofing peeled off. The roof landed on homes immediately to the east of the apartment building. Looking now at the day one convective outlook, we can see that the central portion through the southwestern, southeastern, up through the New England area is all under a general thunderstorm outlook, but portions of western Nebraska are within the enhanced outlook, with the remaining portions of Nebraska extending up through southeastern South Dakota, southwestern Minnesota, and northwestern Iowa are all under that slight risk. Nebraska being, as I said, the western half being under the enhanced risk. And then Michigan, our area in West Michigan, was under that slight risk, extending across the lake into southeastern Wisconsin. And then in all the surrounding areas and states spanning from Colorado and Wyoming all the way to the eastern seaboard, we see under a marginal risk. So quite a lot going on with this categorical outlook this particular day. And it stated, quote, severe thunderstorms are expected over parts of the central high plains where large hail, damaging wind gusts, and a few tornadoes are possible. Other severe other severe storms may also affect portions of Wisconsin and lower Michigan, end quote. They were in fact spot on with that particular outlook because that's exactly what happened. And in looking at the tornado outlook, we can see that western Nebraska is under a 5% risk, with surrounding areas being under a 2% risk. But that category, the categorical outlook that we were under, just to very quickly go back a slide, which was the slight risk, spawned that 2% tornado risk as well. And it goes on to forecast what in reality indeed proved true. Quote, a remnant shortwave trough is moving across western Wisconsin this morning. Strong heating ahead of the feature over southeast Wisconsin and southern lower Michigan should aid in the redevelopment of scattered strong to severe storms by early afternoon. Forecast soundings show sufficient cape and mid-level wind fields to promote damaging winds and some hail in the strongest cells. A few supercells are also possible, especially across central lower Michigan in the vicinity of a weak surface boundary. Storms will track southeastward through the early evening before weakening. End quote. So now let's look at the radar data. We can again see to the north a tremendous amount of rain extending up through Mecosta, Isabella, Clare, Osceola counties to where the rain the rain showers now extend into the Detroit forecast area. The shoreline of Ottawa and Muskegon counties to our west was under a special marine warning and then was later on extended down through Ottawa, Allegan, Van Buren, and St. Joseph, or that is through Berrien counties. And we can see portions of Muskegon, Ottawa, Kent, Ionia, Clinton, and Shiawassee counties all under severe thunderstorm warning. So as these systems came across the lake, traversing from the northwest, taking a slight southeasterly path through our county, we can see how these multi-cell systems converge once they impact our county and they bow out, generating a squall line, a QLCS, a quasi-linear convective system. And as such, we see multiple severe thunderstorm warnings and confirmed tornado warnings. Now, we also see some pretty impressive hail cores in this storm as well, too. 2-inch hail cores. That's not something that we typically see this far inland. Based on my experience thus far, oftentimes we'll see hail cores populate over the lake, as we can indeed see in the area in the special marine warning, and then they will gradually weaken as they make their way further inland. But some of these storm cells maintain their strength impressively to indicate 1 to 2 inch hail on GR level 3's program. And so we can see as that squall line being bowed out, indicating that strong outflow, we can see that as that strong outflow impacted Kent County, we can see that's when that severe tornado warning was issued, that confirmed tornado warning, I should say. Now, looking more closely at it, we can see that northeastern Kent County was already under a severe thunderstorm warning before the squall line impacted that produced the tornado warning. And as this made its way down from Ravenna, Coopersville, in Muskegon and Ottawa counties, respectively, we can see that, as we have seen before, this tornado impacted southeastern Kent County. There you can see rotation clearly indicated on radar, and then as it extended from the northwest, traversing southeast through Ionia County, we can continue to see those tornado warnings generated as well. Again, we see a strong outflow boundary, no surprise due to the bowed nature of the squall line on reflectivity. Once again, looking more closely, we can indeed see a hook echo on the leading edge of that squall line near the Lowell Saranac areas, and GR level 3 thus indicating rotation with the ring icon there as well. That severe thunderstorm warning followed that squall line all the way until the central to eastern portions of Kent County were under that confirmed tornado warning that particular afternoon and evening. On velocity, as I already mentioned, we can see that strong outflow boundary, and there we can see to the west of 96, we can see that strong outflow boundary all of a sudden converge into rotation, into a velocity couplet just northwest of Lowell, extending down through Lowell and terminating in Ionia County. There's a picture of the start of the tornado. And interestingly enough, this tornado, even though rotation was still present, only briefly touched down in the city of Grand Rapids. And we'll take a look at the damage photo shortly because it actually occurred right across from where I worked at that time. Although, because it was after 5 o'clock, I was not working across from the tornado at the time, but nevertheless, it occurred right across from where I was currently, or from where I had been working at that particular time. Was this rain wrapped? Yes, indeed. It was, in fact, a squall line, as we've been discussing. Was there a hook echo? There was a hook echo in terms of the overall rotation in the storm. You really have more of a bow echo here, I would argue, when the tornado itself impacted downtown Grand Rapids. We do see a well-defined velocity couplet with the velocity product. And overall, was this radar detected? Absolutely. And so the takeaway here, again, no surprise, multiple severe thunderstorm warnings were issued for Kent County prior to a tornado warning being issued. We see multiple cells converging into that squall line, bowing out in the middle once it impacts our county, producing a strong outflow boundary that itself produced a tornado. Now, here's the thing I want to mention about this is that when you have a tornado such as this embedded in a squall line with a strong outflow boundary, it can be hard to spot because tornadoes embedded within straight line winds are hard to spot, especially when the wind is great enough that it's just wrapping that entire thing in rain. Here's a picture of the damage photos in Belknap Lookout here. You can see, and I'm sure that those of us driving along the Ford Freeway have all seen those photos of, or rather, we all know exactly where these apartments are. They're across from the Spectrum Health Medical Center campus across the Ford Freeway there, close to the college exit. We can see how that tornado just completely ripped the roof, not just the shingles, but it just completely lifted the roof right off those apartments, completely exposing the residents in those apartments. Pretty impressive damage, actually. Thankfully, though, nobody was injured or hurt in this particular tornado on September 11th of 2019. Surprisingly, even though radar would indicate strong rotation continuing from this squall line as it continued to traverse through Kent County down into Ionia County. Surprisingly and thankfully, the only tornado that actually touched down was in this short area just to the north of 196, the Ford Freeway in the Belknap Lookout neighborhood. Well, this brings us now to our penultimate tornadic event of the evening, April 10, 2021. We won't spend a great deal of time talking about this one because, quite frankly, this was virtually impossible, I would say, to detect on radar. But nevertheless, this tornado was an EF0 tornado that struck down in the mid-afternoon hours. At 3:18 p.m., an EF0 tornado with maximum wind speeds of 72 miles per hour, struck down in the Preservation Lake subdivision in southern Kent County, just south of Cutlerville, and east of Byron Center in Gaines Township, causing damage to 6 to 12 homes. This all according to the official event narrative. Even though this was a relatively weak tornado, it did inflict $75,000 worth of property damage in its short lifespan. It had a path length of 0.6 miles and a maximum width of 65 yards. Thankfully, no injuries, but nevertheless, impressive, unfortunate property damage for this weak tornado that was only briefly on the ground. Looking here at the day one convective outlook issued at 1630Z, we see that we were not under any kind of marginal, slight, enhanced, moderate, or high risk at the time. We were only in a general thunderstorm outlook, no categorical outlook, like I said. Now, directly to our south in Indiana and Ohio, extending all the way down into Florida, and continuing along the eastern seaboard, we do see all of those states in the marginal risk, with the Florida up through southern Georgia in the slight risk category, but we were not under any such risk. And the convective outlook stated, quote, an occluded low over the middle Mississippi Valley will move slowly northeastward through Indiana by tonight. Clouds are widespread in the warm sector of the system, north of the widespread convection along the Gulf Coast, and mid-level lapse rates are relatively poor. Pockets of surface heating and cloud breaks, mainly centered on Ohio, will support steepening low-level lapse rates and the potential for isolated strong gusts with prefrontal convection this afternoon. The tornadic risk again did not impact Michigan in any way. We see the areas previously in the marginal categorical risk were all under the 2% tornadic outlook as well. And the outlook goes on to say, quote, farther west and closer to the surface cyclone, cold front, somewhat richer low-level moisture but cooler surface temperatures will tend to limit buoyancy this afternoon. While low-level and deep layer shear will be sufficient for some threat for low-top supercells, the poor thermodynamic environment suggests that any tornado threat should remain rather limited. That's why it's surprising that this storm actually produced a tornado at all. We can see rain bands extending from the south, moving up north through Kent County. Looking on radar, we do see a clearly defined outflow boundary from that storm. Would I call this a squall line? Yes, it's a weak one though, and not very well organized at that. It's certainly nothing severe, at least by the looks on radar. And apart from that clearly defined outflow boundary and the subsequent severe thunderstorm warning that was issued, nothing to immediately indicate that a tornado had touched down west of the Caledonia neighborhood, just to the east of US 131 across the southern Kent County border. Looking more closely at this radar loop, again, nothing particularly impressive about these storms. They bear watching, and that strong outflow boundary is definitely worth watching, depending on how strong it would intensify. But the convection itself would not immediately indicate the presence of a tornado. Looking at a still image, again, the convection itself, frankly, is just not that impressive. But look at the velocity now over on the right. You can see that outflow boundary just beginning to impact the southern border of Kent County. You also, I believe, can start to see some inflow being generated by that tornado as it touched down, just to the east of US 131. To correct myself, I may have said this struck down to the west of US 131 earlier. It was to the west of Caledonia, to the immediate east of US 131. That area of inflow would indeed really and truly be the only indication that there was, in fact, a tornado that had touched down. It was not excessively rain wrapped, as we will see in pictures, because this was occurring along the leading edge of the storm cells. We do not see a hook echo on radar. We do not see a velocity couplet on radar. Again, I define this as a QLCS, but it's a weak one and a disorganized one at that. So honestly, I will leave this to the professionals to determine whether or not this was in fact even a QLCS at all. All that to say, this was not a radar detected tornado. In looking at this, I could determine simply on radar that there were areas of concern that indicated beginnings of rotation, but that in and of itself was not sufficient to determine that a tornado had touched down. So my takeaway here is on this penultimate tornadic event of the evening, don't rely only on radar. Ensure that you are actively observing weather conditions in your area, whether through a weather station network such as the one that I utilize, the Ambient Weather Station Network. There's others as well, such as Weather Underground, through a weather camera, or simply, and most importantly, safely, just simply observing conditions outside your work, home, or vehicle, as the case may be. But you'll notice now, looking at photos of this tornadic event, courtesy of the Grand Rapids National Weather Service, you can see in the photo that this resident of Grand Rapids took, you can see now that area of inflow, and you can see what I believe, again, it's not clearly defined on a still image, of course, but I believe is a wall cloud lowering from the base of the storm, and you can see where that inflow is developing. You can see how it tore siding off homes, that it tore shingles and roofing materials off homes as well. It knocked down trees. And in the bottom two pictures, you can also see that vortex, that funnel, impacting the ground, moving along that street in Gaines Township at approximately 4:19 p.m. And it was cool to actually see this tornado being captured, likely by home security footage at the time, although that's not confirmed in these images here. But just looking at these photos that were taken, I believe these likely were taken through private home security cameras. It's just very interesting to see what this storm actually looked like. And so here is the damage path of this particular storm, and you can see that it's relatively short. A tricky one, to say the least, to spot on radar. And so this now brings us to the ultimate, not in terms of damage, but in terms of our sequence this evening, the ultimate tornadic event here on June 26th of 2021. This is the last tornado to date thus far that has impacted Kent County. And this tornado struck on 3:23 p.m. and ended about a minute later at 3:24 p.m. It was an EF0 tornado with maximum wind speeds of 72 miles an hour, with an approximate length of 0.55 miles, with an approximate width at the widest point of 50 yards, and it inflicted $50,000 worth of property damage, even though it was only on the ground for about a minute. Now, the official episode narrative stated, quote, "A low-pressure system and warm front combined to set up conditions favorable for the development of several weak tornadoes on June 26th. Storm damage surveys were conducted, and it was determined that 2 EF1 tornadoes occurred and that several EF0 tornadoes occurred as well." Now, this not, of course, all occurring in Kent County, but nevertheless, the larger context showed how 2 EF1 tornadoes had struck and several EF0 tornadoes had struck. The event narrative stated, quote, "An NWS storm survey determined that an EF0 tornado was on the ground for a minute with a path length of 0.6 miles. Several trees and limbs were snapped from Bennett Street and Cumberland Avenue to Virginia Street east of Cumberland Avenue." The convective outlook shows that we were under a slight risk that day, extending down through northwestern Indiana into central Illinois, and then moving down through the Great Plains, through Missouri, through Oklahoma, through southeastern Kansas, as well into the corner of northwestern Arkansas, down into Texas. Most of that region of the country was under a marginal risk, with portions of Oklahoma, New Mexico, and Texas also under a slight risk as well. We being under a slight risk caused the SPC to state this, quote, "Relatively strong heating is occurring along this boundary, and ample moisture is present to the south. This will aid in moderate mid-level Cape values and the development of scattered thunderstorms along this entire corridor later today. Low and mid-level wind fields are southwesterly and relatively unidirectional, but are strong enough to pose a risk of some convective organization. Bowing structures as well as occasional supercell storms are expected. Damaging winds appear to be the main threat, but sufficient shear will be present to pose some risk of a tornado or two as well." Now, interestingly, again, remember we're under this slight risk here in the categorical outlook, but we're under a 5% tornado outlook. And the outlook goes on to say, quote, "Scattered storms to severe thunderstorms are possible this afternoon from east central Missouri to parts of lower Michigan and over parts of the southern high plains. Damaging winds and perhaps hail are possible in those areas, along with a tornado or two over the Illinois-Michigan corridor." And they absolutely nailed this, because this is exactly what happened as we now turn our focus towards radar for the final tornadic event of the evening. We can see in the broader context, we can see flash flood warnings for Illinois and Indiana. We can see along the southern coastline up through the western, or rather the eastern coastline of Lake Michigan, through Berrien, Van Buren, Allegan, and Ottawa counties, the special marine warnings that were all issued. We can see this squall line with indeed bowing structures present, as the SPC outlook had stated, moving its way up from the southwest. We can see severe thunderstorm warnings sandwiching Kent County in Allegan, Newaygo, and Mecosta counties specifically. And we can see rotation indicated on radar with confirmed tornado warnings issued up north in Mecosta and Isabella counties, as well as Berry and Ionia counties. So this is the overall structure of the storm in terms of its reflectivity and velocity. But let's now look more closely. We can see, first of all, that Van Buren, Allegan, and Ottawa counties are under that special marine warning, and oftentimes when that occurs, severe thunderstorm warnings are sure to follow when those systems make landfall. Allegan County was under a severe thunderstorm warning. We can see that Kent County, however, was not under a severe thunderstorm warning, even though Allegan County was. Now, this is a decision that SKYWARN team leaders of various counties have to make. Do you change your net status based upon warnings in surrounding counties? I'm not a Skywarn team leader, so that's certainly not my call to make, but nevertheless, I think it would be helpful for all of us to observe weather conditions in surrounding counties and be especially vigilant when we see warnings of any sort issued in counties that immediately border us, because same storm event may very well impact our county in the same way, regardless of whether warnings are ever issued or are issued after the fact. Looking now much more closely at reflectivity, we can see that there is indeed a hook echo structure to the most severe convection just to the northwest of Lowell, to the immediate east of the Forest Hills neighborhood. And we can also see, as this loops around again, we can see a minor velocity couplet as well on the velocity product, looking at the base reflectivity with the half a degree angle. And letting this loop around one more time before advancing to the next slide. Again, there we can see that small but nevertheless clearly defined velocity couplet when that tornado impacted Kent County. Looking now at the still image, we can see how the reflectivity is generating the beginnings of a hook echo on radar, and as mentioned, we can now see even more clearly when we pause the image the velocity couplet over on the right side. So our final radar observations of the evening indicate that this was, as many others were in our history, rain-wrapped, that there was a hook echo, or at least the beginning of one. We can see a minor yet clearly defined velocity couplet on radar. We can see that just as the SPC had forecasted, a QLCS with bowing structures impacting our county, and that this was indeed very well detected by radar. Ensure then that you can shelter in place whenever we have these severe storms, especially squall lines. Squall lines are just not a good environment for not producing tornadoes. They're a great environment for producing weak tornadoes in our county, but they are difficult to spot and they can be even harder to see on radar. So they're best to be avoided if at all possible. Here is the final damage path photo of the evening. We can see the approximate damage path to the northwest of the town of Lowell, more in rural Lowell at the time, making its way through fields and rural highways, or rather, less traversed roads at the time, just to the north of the Grand River. Now, finally, at the conclusion, what would be the takeaways having looked at each of these 10 tornadic events in detail? Well, here are my conclusions, and I would encourage you to draw your own conclusions as well. I personally recommend watching radar before storms impact Kent County. I've often watched storms before they even enter Michigan in order to get an idea of when, where, and how severe the impact may be once it reaches our area. And I know others who are radar observers do as well, and I appreciate the work that they all do in making this a team endeavor. I would strongly encourage us all to pay special attention to be on the lookout for hook echoes and velocity couplets on radar. We need to get practice at this by observing tornadic supercell storms in other parts of the country as they occur. Pay attention to the larger weather patterns in the United States because you will find great opportunities to observe radar in other portions of the country. But once storms do indeed reach Kent County, we need to be very carefully observant of the radar signatures in our own county. Other counties, while we do have liaisons for them and while we do want to pay attention for them, once the weather system is impacting our county directly, that is where our greatest attention and vigilance needs to be focused in order to not miss radar observations that we otherwise could make if we are very closely watching what's occurring strictly within our own county. As has been stated already, and so I won't belabor the point, squall lines in our county increase the likelihood, the historic likelihood for tornadoes, and they have often in our history produced tornadoes faster than radar has been able to update or the National Weather Service office has been able to issue warnings. So be especially alert when squall lines enter our county. And above all, do not take severe weather for granted. Tornadoes, thankfully, statistically, are unlikely to kill or injure people in our county. It has happened. I would refer you to part one for more details on that. But statistically speaking, it's not likely to happen. But they can and they do produce significant and costly property damage in a matter of moments. We can only truly take storms for granted after they have exited our county. And while radar is critically important, we need to also know how to observe weather conditions in our area if severe weather strikes before radar can update. Above all, of course, we need to stay safe. Stay safe, folks. We are storm spotters. We are not necessarily storm chasers. Again, thank you for your time. Thank you for your attention. Thank you to all my fellow teammates on the Kent County SKYWARN team, to my team leader, Tom Baylor, amateur radio call sign KBATYJ, for his encouragement and impetus in this particular project. I appreciate all the contributions that my teammates on the Skywarn team make to a new member such as myself attempting to learn the ropes even more now that we're heading into a new year with a new spring storm season. Feel free, as I said, to contact me directly. If you have my contact information, awesome. Go ahead and call me, text me, or just feel free to email me or simply post a comment in the YouTube video below, and I would be more than happy to respond. With that, have a great evening, folks. Let's make spring of 2022 and in following severe storm seasons here in West Michigan great ones. Let's be vigilant. Let's stay alert. Let's ensure that we sharpen and hone our skills to the best of our ability to achieve the greatest standard of individual and team excellence that we possibly can. With that, folks, this is Colin McConkey, amateur radio call sign KE8RXN. I will be clear. Have a great evening.